All right, let's go and get started. Um, First thing, honor students and graduate students, plan sticking around for about 5, 10, maybe even 15 minutes after class. So if you're in the honors college or you want the graduate students, stick around. For people in Zoom land, do everything you can to be here in person on Thursday. Why? Because I just want the entire class to be here together one time. If you can't, no big deal, Zoom land. Come join us through Zoom. If you can, great. It would just be nice to have one last time during the semester where we are together. For the final, I think it's close. Probably should have it posted by Thursday, Friday, or Saturday, somewhere in that ballpark. The closed book is going to be a little bit different. Closed book is going to be respondents, but it is going to be multiple choice. Very simple reason. I've got to grade things very quickly. I leave town on the 16th, and I will still be grading, but I would prefer not to be grading. The open book and the closed book are both due by the end of our exam time, Thursday, but obviously I will be very happy to look at grades that come in early so I can get them done. There's very little late submission here. That's just because grades are due Tuesday afterwards. If for something comes up, and things are coming up, that is fine. That's what the life we're living in right now. Make sure that I know. Just getting incomplete. You can finish up the exam after the end of the semester. Changing incompletes are easy to do. There's one little caveat and one little Achilles heels with incompletes. That is, if they are not changed to an appropriate grade within 12 months, they are automatically converted over to an F. We don't want that. That has only happened once in my professional career, and I give out incompletes almost as much as I give out chocolate. I'm happy to give them out. We have flexibility, we have things, and this semester has been weird. Obviously, don't unless you have to, but if you need to, no big deal. In terms of the open book, it will largely be the same. I did tell you the one question I'll be asked. That'll be on the open book. Yes, Gabrielle. Probably somewhere between Thursday, Friday, or Saturday. And it depends on when I get a chance to actually do it. I have revisions for a paper that I have to get in by Thursday. I expected to be able to do it yesterday and today, and I've had no time to do it yesterday or today. And I have completely booked scheduled both Wednesday and Thursday. So I don't know when the hell I'm going to get that thing done. That has to be done by Thursday. And that's when I get to put the last touches on the exam. No, the closed book will be on Respondus. You could just do that at home, and you could do that on your schedule. And as before, there'll be no time limit for it. You just do it, and most importantly, from my perspective, it's just straight up simple honors code. The only thing different about this closed book is it will be multiple choice. And the reason it'll be multiple choice is so it's automatic grading. It's automatic grading so I can turn things around more quickly. It's not the ideal. It definitely doesn't allow for partial credit, but it does allow for multiple guessing. So I mean, there's pros and cons, I guess, either way. Yeah, it'll be comprehensive with a bias towards the last unit. So it is comprehensive, but since everything in stats kind of builds off each other, all that material is really largely been comprehensive going all the way through, and it will be prejudicial to the last period. Questions with that? We are not meeting in person at all next week. And on that note, and I don't know when these will be, Sean will have 1 hour available. I'll have 1 hour available. Sean looks like it'll probably be Monday. I will probably be Tuesday. For anyone who has any questions about the data or the research question, as I kind of mentioned before, but I'll stand by again. You are cheeky. You do not like to answer the question you've been asked. Answer this question. You're like, yeah, nah. And you come up with your own question. Now, sometimes you come up with your own question because literally it's, nah, this is what I want to do. That's fine. There's a decent, justifiable reason for doing it. If you make a good argument for it, I would just grade you on what you provide me. Now, caveat, You got to make a decent argument, and you got to tell me what you're doing. If you don't tell me what you're doing, I don't know what's going on, and therefore I can only base what I'm actually seeing. So treat me like an idiot, walk me through hand in hand, make sure I understand all the points, right? But with the last test, there were some issues where clearly people missed what the question is. The question is explicit. I'm not apologizing for how the test was written. I am acknowledging the fact that each of these questions is about half a page plus for a question that describes the data, describes the research, describes the justification for it, describes what you're actually going to do with it. So I'll fully acknowledge that can get confusing. And additionally, you then have the data, and each of the data means something. Any one of those things can get confusing. But treat it professionally. We'll be available for 1 hour each if you have questions about, like, what is the question? And you can't come in with that. You're like, this is what I think the question is. Is this correct? This data is telling me what? I think it's telling me this. Happy to do it. Not a situation where you can just come in and say, I don't know what to do. Cool, sorry. But really to allow you to get some more information about what you got. If you go rogue, and I guess you wouldn't know you go rogue until after the test, but if you go rogue, just give me information. Let me know what's going on. If I ask you for justification, a lot of times I think justification just means tell me about normality or variance structure, stuff like that. No, justification is everything. It's actually kind of your methods. The data analysis section of your methods is really just a justification. Sometimes it's really short. I use this procedure with this package, and you get the citation, done. Very often it's pages long of explaining what you did with the data, why you did it with the data, what you were actually thinking, how this addresses a particular point with that data. Just give me that. We talk about it, but basically in the last test, it clearly would be beneficial to sometimes be maybe more explicit about it so you can really represent what you want. In terms of the test, really binary. Like binary I haven't seen before. And normally, normally we're sort of left skew. Anyways, lots of B's, some C's, and very few D's and F's. This time, wicked high A's or low C to kind of D-ish range. We're sort of in that ballpark, which is unique.
This on the web.
That's great. But so you got perspective there. Any questions with that? And there's still no one I would say is off the rails. Cool. Okay. We got two things today.
Sorry to speak in your ear. I have a question that I have.
Yeah, go ahead, Connor. Connor's talking to my ear. So I'll tell you what Connor says. Go, Connor.
Yep. So the closed book's comprehensive with a bias to the last unit. Does that also go with the same for the open book? Is that going to be comprehensive as well? I mean, it all kind of builds off each other.
Everything builds off each other. Open book and closed book are both comprehensive. Open book is comprehensive because for a variety of reasons. It actually may draw from earlier material, but as much as anything else, you get to make decisions. Good example of the last test when I asked you about population growth, there were choices you can make. And you could have made that as a one sample test. You could have made it as a two sample test. You could have made it as a permutation test. You could have made it as a non-parametric test. There were a lot of different decisions that you could make. Some were directly related with an individual unit. Others were not. You had that freedom. You have that same freedom for the final where it makes sense. In some situations, it will make sense. You really only have one option to go with. And then you just go with that option. Considering earlier in the semester about maybe the first third of the semester, it's really about statistical philosophy and statistical factual information. That's probably more oriented towards the closed book. But the question I gave you as sort of the question I gave you for the test, that includes definitely the second and last unit. Does that answer the question, Connor?
Yes, it does. Thank you.
Yes, it does. Thank you. Okay. Any other questions? Yeah, that was weird. Love it. I felt it was like I was a play-by-play announcer at the World Cup. And there was some protest that went in the field, and then someone tells my ear, don't talk about it, don't acknowledge it, don't see it, nothing's happening. Look at the soccer ball. And they ignore it. So yes, I know you guys are all very sad because of Sunday. I apologize. Not much I could do. It wasn't really our fault. They lost. It stunk. They sucked. 3 times, which is why the Dutch scored 3 goals. Anything else before we get going? Okay, we're left with this question. Florida burrowing owls. Where are you going to find them? Again, mob rule. A show of hands. Where do you expect to find Florida burrowing owls? And remember, they preferentially nest on undeveloped lots. Where do you expect to find them? In neighborhoods where there are a lot of undeveloped lots and few houses? Or do you expect them to find them in neighborhoods where there are lots of houses and very few undeveloped lots? So if you're taking the one with the few houses and lots of undeveloped lots, raise your hand. And everyone except for Nick, who's not allowed to play the game. If you take the answer of lots of developed lots, lots of people with few undeveloped lots, raise your hand. Cool. What's your logic? Yep. Yeah. What's your logic? Oh, cheater. That was a third hand. Yeah, what's your logic, Lucy? Ah, cheating. Cool. Let's find out. So, download the owl_GIS data. It's a CSV file. The actual code to compare the pattern of owl density relative to neighborhood density is nothing more than LM. That's for linear model. Fit, we've already seen, done that many times. We have our model, the y-axis by the left axis with a tilde. Define your data, and that's it. I do put in here to look at both the fit and summary fit because they'll give you different outputs. One of them is the one you want. I want you guys to tell me that as well. And then please write a results sentence. And the structure for the sentence is exactly like in a ANOVA with a little caveat. So put in the evidence. This Excel file has 2 separate spreadsheets. Increasingly, that's the standard that you want. Now, I know we're at the end of the semester. We're just sort of showing this now. But one of the things you want is you want your Excel file, your data file, that has all of the data and all the variable names. But you need to keep those variable names very simple. One of the things that's a very common practice is to have a second worksheet that is available, that is the key. The key defines each one of those variables, gives more descriptive information about it. How do you convert the Excel file to a CSV that you can then use in R? There are 2 solutions, one's good, one's bad. You just save that worksheet. So you just save as CSV with the worksheet that is open, and that will only save that worksheet. There'll be a warning that says, you can only save it, you can't do any manipulation, sucks, don't do it, but you do it anyways. Alternatively, what you can do if that gets you a little bit cagey, it does give me a little bit cagey, is I just copy out the worksheet, put it into a new Excel file with only one worksheet, and then paste it there, and then save it as a CSV. Either of those work. Right.
I had a quick question about it.
Yep.
So he pointed out that there are a bunch of zeros in one column, but all the other columns around it also have zeros.
There's one like column that doesn't have any.
I just wanted to be sure because all the other ones around it have zeros.
I don't know what that is. So let's actually pop it open, right? All right, talk to me.
Owls occupied neighborhoods, if you scroll down a little bit, there's a whole empty space there, but the ones around it, the owls all neighborhoods, the adults and juveniles are all there.
Brilliant. Great observation. How do you solve this? When you go down here, look at, oh my God, there's nothing. All these blank cells. What do? What should be the first thing you do? And I just gave you a hint. Maybe 5 minutes ago. Y'all know you're not supposed to be right every time, which means you should give out answers. Sometimes right, sometimes wrong. Doesn't matter. But quiet never gets anyone anywhere. Okay. I like that answer. That's wrong. You never ignore anything. You could add zeros. Also wrong. Why? Why both of those? We know it's wrong. And do we know enough about this variable? No. So what do? Oh my God, I hate small. You asked, so that's a good question. Like when I said, we'll have an hour next week. Don't have an hour, I'll have an hour. That's a great question. Go ahead. But I also told you, you have something here. You go read. And then look at the key. Number of owls in only those neighborhoods with owls. So anything that doesn't have an owl, which be a zero next to it, shouldn't have anything because that variable is only considering those cases where at least one owl was found. Great question. Good solution. All right. Now here are two good solutions. Ask. Are you all allergic to reading? Okay, my graduate students tend to be allergic to reading. My undergraduate students tend to be allergic to reading. You all allergic to reading? Oh, let's not do that. Let's no. Reading's awesome. All right, get on. You leave those blank. Okay. So I'm just going to install the packages. We really just need ln perm through pacman. We don't need permaco here, but I'm just going to keep it in. We don't need our companion here, but if you already have it, keep it in. Run down. Just to load this. There were a few people with the projects. Remember, the project pathway is specific to how you save the project. So wherever you save the project, any folder within that is part of the pathway. So there are a few people that forgot to put data, even though their CSV files were in a data folder. That's fine. And there are a few people who moved their project what appeared to be afterwards. So they had the project in a location, the project file location, and they moved it out to a larger folder that they called exam 2, which makes perfect sense. But then when the code was run, the code was for data, not exam/data/file, and therefore it couldn't be read. It had to be manipulated. No big deal, easy to fix. A few points off for the exam, but make sure that this pathway is specific for how it runs in your computer. If it runs in your computer, don't move the project file anymore. Leave it alone. If it works for you, as long as you give me the folder with the project inside of it, it'll work for me. And that's kind of a nice rule of thumb. That's one of the things I like about this. And one of the things people are doing so much better in this class than they did back in the day when they walked uphill 5 miles both ways in the Florida snow. Because none of that was true. You couldn't quite trust that what you were doing at home was what it was going to translate when it was given to me. So make sure that you have that. Here, I get a little annoyed with the forward quotes. They're just stupid. And I don't like how R deals with empty spaces anymore. It used to just put in a dot and made life very easy. It doesn't do that anymore. So you get forward quotes. So sometimes, oh, that was stupid. Okay, so I want someone, and I'm going to be doing a little differently today. Ashley, you're starting. That line of code is dumb. And it just dawned on me. It's a mean question because it's not a fair question because it's a hard question. Why is it really stupid? Why is this a definite mistake? Total lots describes how many lots are in the neighborhood, measure of density. Percent developed lots describes a percentage of those lots in the neighborhood that are developed. So 0 means there are no developed lots. 100 means they're all developed lots. And I write a code because I don't want to have a bloody space that says total lots, one word, equals as factor total with space lots. Percent lots equals as factor percent developed lots with spaces. This line of code is stupid. It was a mistake. And everything after I run this line of code is going to be an error because the line of code is wrong. This is hard, so you can pass it. This is a fair one. I'll give you the hint. Total lots as factor total space lots. Do I want this to be a factor? I do not. So that's a mistake. I just got in the habit of doing as factor. So I'm going to change it ever so slightly. We're just going to say total lots equals total lots. Percent lots equals percent lots. We should be good now. So what happens when I make it a factor? It changes the variable. It makes it categorical versus continuous. In regression, both variables need to be continuous. So that was silly. Let's run it. Everything looks good. We did a summary. Look, total lots, percent lots are good. Everything else is looking good. We like that. We do attach. We do our plot theme as we've done before. We still got to fix this because all the old code is going to be wrong. So we just fix that. Line width. Why do I want to fix line width today? See down here, I get this little warning message that size has been deprecated in element line. And now they want line width versus size. Why do I want to change it today? Jeffrey, you're the next one up on lots. We're doing a different pattern today. Well, you don't have to worry about it later. Why else do I want to change it today? Jonathan? Perfect. It will work for today. Size will work for today, but it's telling you the system is changing. Pay attention. Fix your code now. Then when you actually get into a situation in the future, it still works. Because again, we're just going to copy and paste code, right? So I do that. Everything looks good there. And now we run our model. Owl, all neighborhoods, total odds. So these are owls in every neighborhood, even including those places where they didn't have owls. We run it. Do a summary fit. Let's start with that. We get a lot of information. Information's good. It's one of the times we really don't have to pay attention to all the information, though you get it all. Misty, where do we start? Perfect. Start with a p-value. There's two places you'll see the p-value. When you notice the p-value are exact same in both places. Regressions give you parameter estimates. A parameter is, in this case, either alpha or beta. Alpha is the y-intercept. It's where our best fit line crosses the y-axis. That's here. That tells you whether that is significant, meaning does it cross at 0 or not? Rarely do we care about the y-intercept in terms of whether it's the alternative or null hypothesis. We might care where the intercept is, but we don't care really about the p-value. Rarely. Every once in a while, that might be different, but for the most part, we don't. We do care about the estimate. And the estimate for where it crosses the y-axis is at -2. Now, what we do care about is we care about total lots. And as you said, start with the p-value. This is that large or small p-value. That's a small p-value. Since it's a small p-value, we're going to describe the null or the alternative hypothesis. Fantastic. Misty, what's our problem? That was perfect. Victoria, what's the null when we do regressions? When we do a regression, what's the null? That was perfect. I did not think we were going to go perfect. That was perfect. That was awesome. Null is that the slope is going to be 0. And can you please translate what that means, Julie? The slope is 0. What does that mean? Tell me that in lay term. No, that's actually a different measure, and we'll actually get that measure. Not that, Gil. Because the slope means 0. Translate to parent term, meaning you're telling your parents about this. There's no relationship between the two variables. When the slope is 0, there's no relationship between the two variables. The slope could be positive, the slope could be negative. Those are two options for the alternative. The null hypothesis mathematically is that beta equals 0. Beta is the other parameter. Our first parameter is alpha, that's the intercept. Our second parameter is beta, that's the slope. In this case, relationship to total lots. Cool. So, going back to you, Misty, we described the alternative. Therefore, is there a relationship between total lots and number of vowels? Yes, there is. The p-value is small, so we describe the alternative. There is a relationship between total lots and number of vowels. Jamie, what is the relationship? That's all right. What's the relationship? Sure. Yep. Could be. Don't know. Is it really easy to tell from this? No, this is going to be the numeric information. We'll come back to this in just a bit. But what's the best way to approach a bunch of numeric information? What you looking for, Jordan? What's the best way to deal with numeric information? Plot it. Let's look at a figure. All right. Let's plot it. Here's your aesthetic. I want you to do two plots. And there's a very subtle difference between the two of them. I don't know what I normally do, and that is do sort of the return after each comma. And I don't do that so you can actually see both plots together. One of these is useful, one of them is a terror. Do them both. Pay attention to the subtle distinction. And then tell me which one's useful and which one's a terror. Card. All right, the first part is the aesthetics that we've done many times before. Next thing, and what is this going to do? Who did I ask last? I asked you last, Jamie? Okay, Jordan. What does line 53 do right here? Par, parentheses, MF row, C2, comma 1. Great. And what's going to happen when we do 2, comma 1 for MF row? So we're going to have 2 columns, or we're going to have 2 rows. Actually, in this case, we're going to have 2 rows, but does it ultimately matter? No, because if you don't like it, you just switch it. Yeah, so if you don't like it, you just switch it. But we're going to get 2 rows here, because this is MF row. Therefore, we're defining the rows. We'll get 2. We'll run that. We'll run it first. Do we like it? We get our second. Do we like it? Great. Madison, what is the difference between these two figures? Oh no, by the way, I lied. PAR no longer works with ggplot. Sean shared some coding that allows you to set up grids. If you want to put that on Canvas, it's actually very nice. I think I put it as part of this sample exercise for this. That is very nice. Again, I'll leave you some Easter eggs. Madison, what's the difference in these two things? It's the line. What is this one doing? As represented here, this is a truly best fit line. This is the best model that can fit in a nonlinear fashion to the data with the fewest number of parameter estimates. And that's what it looks like. The red line. Nick, why is this what we want? We want this one. Why? They both take into account all the data. Do you like this, Nick? No. No. Do you want to see the math behind this? No. No, you really don't. Really don't. It is a very, well, if you really like algebra, you'll be excited about it. But there are a lot of parameters, 2 squared, cubed terms. How many parameters are here? 2. The y-intercept and the slope. Those are our 2 parameter estimates. Fabiola, what is the relationship between lot number and owl number? Visually. It's an increase. Translate that. Total amount of lots, more hours are found. Chandler, is that consistent with what we expected or not? Except for our cheater pumpkin eaters. It's inconsistent, completely inconsistent. Diana, is it real or is it random? Real. Diana, how do we know it's real? The p-value. You start with a p-value. You always just start with a p-value. The p-value is just where we start. This is a real pattern because our p-value is very tiny. We don't really care about the p-value associated with the y-intercept, though it is very close to 0. That's all that p-value tells us about. What we care about is this biological line, where the null hypothesis Victoria told us is that the line would be flat. This is not flat. This is positive. It is increasing. It's increasing in a way that we may not expect. The more number of lots in a neighborhood, the denser the neighborhood, the more owls you have. That's cool. Yes, Gabrielle? Nope. Nope. It can always go negative. We have negative numbers. What are Floridians allergic to? Cold. And in Celsius, what are all those numbers? They're negative. So what would be the relationship between the number of Floridians in a location and freezing temperatures? There would be fewer Floridians with every degree we go down. It would still be negative, and there might be a few brave Floridians who say, I could do 0. Be fewer that say I could do -1. Even fewer that would say I could do -2. What is the coldest temperature anyone in this room has been in Celsius? Pretty damn cold. And it's called a hot box, and it's -20. Yeah, that's some people with some sick sense of humor. Yeah. Yeah, so it totally depends on the data. Cool? All right, so some things with this image and some things that you want to pay attention to. Visually, each of your data points are shown. These are shown by triangles. You do whatever they want. Their alpha allows them to be a little bit transparent. That is intentional so that you can see when there are additional data points right on top of each other. That's a good visualization thing. When you do regressions, you want to show your data visually. So I encourage it when we do things like box plots. I think it actually provides a lot of value. When you do regressions, you always show it. Alpha allows you to show when there's multiple data points at the same point. You do not want to jitter anything when it is scatter plots. No jittering, because that totally changes the numbers in ways that really defy meaning anymore. The slope is a red line. What is the gray line? And I think we have Dominique. The slope is red line. What's the gray? Right, it is the 95% confidence interval of the slope. So this is the measured slope in red. The true slope is somewhere between this angle, the high of the left side and the low of the right side, and this number, the low of the right side and the high of the left side. So there's a little bit of wiggle that the real slope lies within. Cool? Okay, so let's go back here. I'm going to add in my theme present. Let's make this look a little bit better. That looks a little bit better, right? No gray, a little nicer. Hey, Sean, after you're done with Lauren, Sean, after you're done with Lauren, can you jump on to Zoom? Yep, Emmanuel may have a question. Okay. And I'm going to type in summary fit. Between that figure and the results right here, I want you to give me a result sentence. That's cool. So cool. Cool. What a result sentence. If you want to add it as a label, do. If you just want to write it as a note in your script, do. Want a result sentence. The hint I'm going to give you at this point in time is that it has the same structure as an ANOVA in terms of what we report, with one additional thing that we haven't talked about yet. Give me a simple sentence. I'm up here. I'm in my script because I just want to keep my result sentence in there. I'll copy it out later to a paper. I just want to have it right there in my sentence. Fine with that. I'd write a little bit differently. I'll just say owl's numbers increased with lot number, or neighborhoods with more lots had more owls. But yeah, that's perfect. I might even do it another way. I might say there is a positive relationship between owl number and lot number, provide my statistical evidence, period. Then write another sentence. Neighborhoods with more lots had more owls, and neighborhoods with fewer lots had fewer owls. So I might sort of add in some different information. The first statement, just saying that there's a pattern and then explaining it out. So sometimes you can make it one sentence. A lot of times it's easier to make it multiple, but notice the way Haley did it and I did it, simple. Keep it simple. And then you might write down something one time and you're like, yeah, I don't quite like the wording of it, and then just fix it. But you want to make it simple and clean. Okay, so now, Lucy, give me my evidence. Yeah, what do we start with? Nope. Just like an ANOVA. I love how you have a bunch of people around you who are like, I'm not telling her. Nope. Here, that's a really good observation. I like that. You do have a t-value here. The t-value describes this parameter by itself. This t-value describes this parameter by itself. We're going to record the f value though. What does the f value describe, Lauren? The f value describes the entire model, both the y-intercept and the slope. That's the distinction between them. The t-value, and that's clever, I like that. The t-value only describes one parameter though. We're describing the whole model. And therefore we provide the f value. So, f okay. Oops. Oops. Love it. Love it. And Gabrielle? No. We do frequently put the model in the figure. So we'll put y equals, and then we'll put the intercept plus, and then we'll put the slope times x. We frequently do that. It's actually a really valuable thing to show those two different parameters. And we haven't talked about it. I haven't told you. Just wondering. Everyone gonna give me? Yeah. I do want the r squared. No. And I want the adjusted r squared. 0.18. We want all of that. That's a good result sentence. When there are more lots, owls are more abundant. Now, I'll be honest, I'm gonna do a little bit of editing. I like to talk about my subject first. Owls are more abundant. That's me being American. If you want to be German, be your German self, go with the subject at the end. But I like getting to my point right off the bat. I'm focused on the owls. So owls more abundant when there are more lots. That's perfect. We record the f value, we record the degrees of freedom, we record the p value, and we record r squared. R squared in normal text, you just have to put r, put the caret, and then 2, that's caret stands for squared term. Cool? You happy with that? Brilliant. Which brings up this issue. The effect size. We've talked about this many, many times. I'm going to keep repeating it. P-value is just where you start. For polarity statistics, it's just the first step. It's not that interesting either. All it does is tell you whether to describe the null or the alternative. It just gives you a launching point. If you describe the alternative, it doesn't tell you anything else about it. If you describe the null, you're done. That's easy. The pattern's random. There is no relationship. There is no difference. That's great. But if the p-value is small, you describe the alternative, then you get to do some more fishing. And one of the things that we get to fish for is power. This is the first time we get to play with power. I love power. Value. Statistically, power describes a lot of other things outside of stats. In stats, it describes value. And in this, we're going to describe something called an effect size. The effect size is the correlation coefficient. Correlation coefficient is r squared. Can you tell me what r squared tells you specifically, technically? Does anyone remember from their stats methods? What does R squared tell you technically? It's one of those stupid memorization terms that you're going to want to jot down notes as soon as we say it. What does it tell us technically? Jeff, I saw your hand. Look at Jeff. I saw Jeff say. It has to do with residuals, but the residuals are not part of our technical definition, but it absolutely does. Yep. It's about that error, that epsilon. Madison, then Nick, then Dominique. It doesn't give you any information about slope. Slope is beta. Beta is slope. We love slope. It does tell us about variance. Absolutely, Dominique. It's a correlation between the variables. Yeah, kind of. Chandler. Bingo. Technically, R squared, correlation coefficient, tells you what percent of variation in owl number is explained by the model of total lots. And therefore, in our study, 18% of owl number is explained by this one variable, total lots. I'd be happy to say it again. It is the percent of variation in dependent variable that is explained by the model. Another way to put that is a percent of variation in the y-axis that is explained by the x-axis. The percent of variation in owl number is explained by total lot. And yes, I know, sorry for zoom line, I keep pointing at the screen. So 18% of owl number is explained by the number of lots in a neighborhood. That's the effect size. So all the variation in owl number has to add up to 100, right? Because only 100% of factors can explain what actually occurs, correct? Make sense? So this tells you the percent contribution of your test variable on what you measured. Yup. Okay, here's the kicker. It's 18%. R squared, 0.18. Is that a big effect or a small effect? I'm going to repeat this again, letting you know it's a fundamental trick question. Y'all wrong, except for one person who couldn't have whispered it with a smaller voice had they tried. Y'all wrong. And I'll walk through why, and maybe you'll get it. 18% of the variation in owl number is explained by one variable by itself. Lot number. Neighborhoods with more density in terms of lots had more hours. And 18% of everything on the planet that could influence how many hours you had at a location is explained by one phenomenon. Lot number. Is that a big effect or small effect? Well, you got to start by asking your question, how many things could affect the owl number? Start with that. What's something that can influence the number of owls in a location? Anything. Trees, love it. In this case, presence or absence of trees. These are burrowing owls, absence. Another thing. Predators, love it. Food, love it. Water, love it. Disease prevalence, love it. Curious when it's going to happen. Number of cars, love it. We're playing a game, basically. Whoever doesn't give me an answer loses. Yes, sir. Soil, love it. Number of insects present. Air quality. Love it. Parent pairs, love it. Intraspecific competition, yeah. Interaction with humans. Elevation. Nah, sorry, I'm coming to you. Reproduction. Remember outside pets. Cats, love it. Yes, please. Love it. Humidity, love it. Give me a different part of weather. Humidity is only one part. What's kind of the obvious thing? Humidity and okay, I wasn't going there, but sure. Sure, precipitation. Noise pollution. Think we're done? How many did you just come up with? 20. Each of those, if it was random, would contribute how much to the overall percentage? Again, it has to add up to 100. So if it was random, on average, how much does each of those factors contribute to our number? 5%. We have 20 examples. If each of them contribute, and it has to add up to 100, on average, each of them contributes 5%. This one variable by itself, lot number, 18%. Is that a big effect or a small effect? That is a large effect. A lot of times you'll get people, and they're normally physicists and chemists, who talk about things like R squared have to be 0.9 to 100, and that is large. 0.7 to 0.9 is moderate. Anything below that is really non-significant. One, that's stupid. Why? Why is that stupid? 0.7 below is non-significant. Why is that stupid? Stupid. Why? Why? What tells you about significance? P-value. R squared doesn't tell you anything about whether there's a real pattern or null pattern. P-value tells you about that. And then what does that assume when you have to require 0.9 and above? Very few influential factors. Probably a very highly controlled experiment. That's wicked cool. Love highly controlled experiments. This is an observational study. Observational studies are open to every single variable on the planet, maybe even extraterrestrial variables. We didn't talk about UV radiation. Could that influence our numbers? Of course it can influence our numbers. Absolutely. Do you think it's going to have as big of an effect or smaller effect than lot number? Probably smaller. When you answer the question about effect size depends on the number of expected contributing variables. If there are a lot of expected contributing variables, then a small R squared can be highly meaningful. When there are very few contributing variables, then a small R squared really isn't very meaningful. But if I were to offer you a panacea, an elixir, that gave you an 18% improvement on your understanding of biostats and your ability to succeed in the final exam, and it was just a small little panacea, would you want to jump on it? 18, Nick's like, no, I'm good. Did I really see no? No, that's what I'm saying. That's all there is. Just 18% from one thing alone. You do it. On average, 18%. No question about it. Improvement. Wherever you are, you're 18% better. You gonna take that? Oh, hell yeah. Hell yeah. I do every time. I give you so many elixirs. You just gotta take them or not. That's, that's taking a camel to the water. It's not whether you drink or not. We cool with that? Don't get trapped by effect size. R squared is very important. I do apologize. We're towards the end of the semester. This is one thing we're not going to be able to repeat many times. So I'm going to use this one chance to say it. When you think about R squared, start by thinking through how many variables should be influencing the system. Give me 1/2 second. I gotcha. If it's observational and field-based, there's a lot of things that should be influencing the system. An 18% contribution is large. If it is an experiment or lab-based, not really an experiment, if it's lab-based with a very tightly controlled experiment, 18% is small. It totally depends on the system. How long would it take to see the sweep of an adaptation in a population that has a 6% effect on reproductive success, as an example? Take 6 generations. That's it. Wicked short. 6% contribution is enormous. We talk about selection pressures. Just wipe the population immediately, fast. Did I see a question? Oh, yeah. Oh, it's just your normal R squared. The adjusted R squared just penalizes you for how much you test. It's kind of like a post hoc test when we use the adjusted p-values. It just makes it a little bit harder. It cheats you back a bit. It's more conservative. It's a better approach. Cool. Okay. Permutation tests. The exact same thing, but it's LN perm. The exact same code, get the exact same answer, but it's LN perm. When you do perm with a capital P for probability, you are doing the simulation. Therefore, you won't have an F value. You'll have iterations. But you still report the same information. You might report iterations. They report degrees of freedom, report p-value, report R squared. You'll notice the answers don't change. But you still do what is appropriate for the data or appropriate for your philosophical choices. Code is right here. I'm so sorry. One more time with a question, Julie. I'm missing something. When we get to the correlation test again, below, sure, happily. But you get the same basic results. Tells you a number of iterations right here. It does give you an F value because the F value is for the entire model. Don't hesitate to report it. You know, hey, you can always generate it even if you do a permutation test as an ANOVA. Nothing really changes. It's just which approach is appropriate for the data. And you should do what is appropriate for the data. Questions with this? Yes. Well, let's do it. Let's do it. When you do a lowercase p, it doesn't do the simulation. It gives you the straight data. So if you're going to do a permutation test, I would encourage you to actually take the simulation, do the approximation, resample the data. And I definitely have my bias, my preference. Cool with that? Okay. Last thing. Correlations. Correlations are actually going to segue perfectly into principal components, the topic that Sean's going to be introducing. Correlations describe the relationship between two sets of variables without identifying a dependent or an independent variable. They're just the relationship. It's not that one is predicting the other, one is influencing the other. It's just how are two things related to each other? One of the benefits of this is it's a clean, non-parametric approach, in particular, the Spearman rank correlation. The code for it is relatively simple. Core.test, notice it is X comma Y. There's not Y tilde X. You're not building a model. Y tilde X is you're building a model. In this case, we're not. We're just looking at the relationship between two things. You don't have to have it in this order. It doesn't have to be X and Y, but that's just the general rule of thumb. Because normally the first when you use a comma is the X-axis. So that's the way I do it. X variable, comma, Y variable. You have to define your method. Either Pearson or Spearman are the most common. Spearman is a non-parametric approach. Therefore, you probably want to use Spearman. When we run it, we get that. There's a few caveats with this. They're kind of obnoxious. One, you get a p-value. That's cool. That just tells you whether you describe the alternative or no. You get a row value. This really just tells you whether the relationship is positive or negative. R squared comes from squaring rho, so we know. That's where R squared comes from. You square that term, you get R squared. For that term, it's just positive or negative. If it's negative and you square it, what happens? It becomes positive. So rho describes whether you have a positive or negative relationship. But there's a caveat when you do correlation tests, and that is you don't have a trend line. You don't have a model. So when you graph them, if you choose to graph them, you should not be putting in a trend line. Not for these. You are literally just describing the p-value and rho. Where if rho is positive, you can describe that these are positively correlated. And if rho is negative, you have to describe that these are negatively correlated. But you don't know the slope, you don't know the intercept, and therefore you might be asking your question, why? Why do we do this? Is anyone asking themselves that question? Great. The reason we do this is actually the basis for a lot of statistical approaches, like principal components, where what you do is you look at correlation matrices, covariance matrices, which are two ways of saying basically the same thing. How not just two variables relate to each other, but how do 20, 30, 40 different variables relate to each other, all at the exact same time. And then using matrix algebra, we can actually start to pull them apart to look across n-dimensional space, which yes, we're going to have to do in injections, which then allow us to describe characters that otherwise could not be measured. Where you will see these nowadays, in this particular test nowadays, correlation test, is not in science. Sometimes you see it in education literature, sometimes you see it in business literature, never in science. This is not what we do anymore. But this math is the basis for a lot of different types of approaches like multidimensional scaling, cluster analyses, principal component analyses, factor analyses, pathway analyses, where it really is about looking at the correlation between many, many different variables at the exact same time. You might see these in old papers where correlation were used a lot because you were generating these tests by hand. And it's actually pretty easy to do by hand. Pretty cool. And it gives you really good information. But for today, not really necessary. Now, Julie asked a very good question. What the hell is going on there? Cannot compute exact p-values with ties. What do we do when we do non-parametric approaches? What do we do to the data? We rank it. And what happens when the data is by itself like 0.01 and there's no other data like that? It just gets a rank, a whole number. What happens if there are two 0.01s? You have to take the average of them. Those are ties. When you get ties, your p-value is approximate. No, I mean, come on, we're talking approximation. It's still the same bloody thing. In this case, is that a small p-value or a large p-value? Tiny. Can we describe the null or the alternative? Alternative. Are these related or not? They are related. Absolutely. Do we know how they're related? It's positive. Zoom in. I'm pointing at the screen. I'm pointing at row. Can we do anything else with it? Not by itself. But now we get Sean. You ready, buddy? Simon, you got to put on the AirPod.
What is your setup here?
I have this is actually a recording thing, so you got to wear the AirPods so you can.
Oh, but this is separate than that.
They're separate than that.
And what's up there? The Zoom
That's
projecting from your
here.
R over here?
From there.
I see, I see.
Put this in. Come the other way. Give me a thing. Give me a thing.
My laptop.
You see it?
Yep, that's it.
Where'd it go? Yeah, put this in so they can hear well.
Sweet.
Okay, I'm every way.
I'll get to the. What is this one? This one's this one? Oh, cool. Okay. So Dr. Allen spoiled a lot of what I was going to talk about factor analysis and principal component analysis. What he said is true. It's like a perfect segue talking about correlation into this kind of concepts. So you guys just went over regressions, which is correlating one continuous variable to another continuous variable. But what if you have 3 continuous variables, or like 4, or like 5, or you try to, like, I don't know, measure my size and I am described by a million different continuous variables? How would you do that? You're going to do a regression for each variable? It's a little unrealistic. And so what they do instead is something like this, a factor analysis or a principal component analysis, which is essentially doing that. It's going to, oh my gosh, which one is it? So many buttons here. It's going to reduce all of the data that you have, all these different variables, into something that's more manageable. And that's kind of the take-home part for these kind of statistical analysis or methods. Like Billy said, like I kind of just said, it's very similar to a regression. A lot of the math is very similar. It's really just finding those correlations between all these continuous variables and then trying to make sense of it. Regression, you guys literally just made one of those. But if you had one more variable, where would you put it on here? If you had a third variable, something else, you had owls, you had plots where they were at, and then you had how fat the owls are, where would that go on this plot? Z, yeah, it would be the Z axis, right? It would come out towards you. What if you had another one though? Where would that go? X, oh, there was an X, W, whatever direction, right? And so that's what principal component analysis does a really good job of, is it takes all of those different variables, it measures how correlated they are to each other, and it creates a n-dimensional axis or space in which these variables are related to each other in space. which is like a lot of jargon and lingo, but it's not that different than what you just did with a regression. So it's not very conceptually challenging or anything like that. I think it's very straightforward, right? You just have a bunch of variables, bunch of continuous data, and you just want to see how correlated all of them all are together. But you can't visualize 10,000 dimensions on a 2D square like this. I mean, you can try, but it's kind of hard. And so what the principal component does is it's going to condense how all these different variables are related to each other or correlated to each other into their principal components. How, like, the most, let me show you an example. This is one that I did on beauty berries to measure the physiology to how different populations grew through each other. They didn't group very well. As you can tell, all the blue, white, and yellows are kind of all sprinkled in. But the idea behind it is that there were a bunch of physiological traits such as respiration, photosynthesis, stomatal conductance, which is how much they open up their stomatas. And we measured that, and I ran a PCA, a principal component, to see how the correlation, or not very much correlation, between those variables plots them on a plot that is made by the principal component 1 or principal component 2. And the percentage here describes how best that describes the variation along this axis and then on that axis. And there's also a third principal component and a fourth, and I think it maybe sometimes goes a fifth. Does that make sense? We're not going to run the PCA. It's actually very straightforward. And it's actually not doing what's called the hypothesis test. You're not going to get a p-value from it. The best thing that a principal component does is it's really, really, really good at visualizing. If you like look at a lot of studies, they do principal component analysis or even principal coordinate analysis. They make really pretty looking figures, and it makes a really great way to represent how populations may group from each other and things like that. And it reduces your data by a lot, which makes it easier to look at the data and stuff like that. Like you can't, like I said before, you can't just measure my size on a plot like that. You would need to do the principal component to make it easier to visualize. But one of the biggest cons, especially what I view from it, is it doesn't hypothesis test. You're not going to get a p-value. You're not going to be able to say something is different from something else without some sort of extra test to go along with it. And so another thing that's very similar to principal component that's a little bit different that allows you to actually do a hypothesis testing is what we're going to do, which is called a factor analysis. And so this one's a little bit more challenging conceptually. Go for it. Oh yeah, so you can actually see better? Yes, of course I can. I think that's the one, yeah. So what the factor analysis is going to do is it's going to take what's called the common variance between all these correlated variables and it's going to load them onto a factor or a latent variable that better describes that variation than the variables do themselves. And so in the PCA, I had all those little variables pushing the different plots, the different points in the plot in different directions and group them on that 2D plot. The factor analysis is going to take all that variation and then it's going to compute a latent variable based off of how well those variables correlate to each other. And then we're going to use that latent variable to be able to hypothesis test or to see if one thing is different than another. You could take all of the continuous variables that describe my size, such as my weight, my height, my density, whatever variables you want to use, and you're going to correlate the best ones to correlate together and create latent variables that better describe my size than just weight or just height or just density. It's a term, maybe just size, that compares all of them together to be your latent variable. And I think the picture does a really good job of kind of showing that, at least this one does. With the principal component, you had all these different factors and how they go on to the principal component. And the factor analysis is going to make a latent variable, and then it's going to put those onto the different kind of variables and make something so that way we can actually do some testing and hypothesis testing and things like that. Does that make sense conceptually? Maybe a little bit. Hopefully if we actually run. Oh, I didn't see your hand. It is confusing a bit. You do get to choose the variable. but you're making an educated choice based off of the factor analysis. So we're going to run a factor analysis. It's going to give us a bunch of results, and then we're going to interpret it and try and define the latent variable ourselves based off of the information that the factor analysis gives us. This won't tell us that because this is a principal component. This is different than the factor analysis, which is why I was talking about kind of the differences. This one doesn't give us that latent variable. It's not going to allow us to say this variable accounts for respiration and photosynthesis rate, which are very heavily related. It doesn't tell us that. The factor analysis, the idea behind it is that it will allow us to have a variable that best describes multiple variables at one time. And then we can, if we have a bunch of data, that's super helpful instead of trying to look at all of this all at once. Like you're not going to run 30 different regressions. Instead, you can do like a factor analysis. So on Canvas, I uploaded a bunch of files, and I'm pretty sure they'll publish that you can find them in the class data section. There's a zip folder that has a bunch of giraffe data and useful information for the kind of test that we're going to run. If you can, please download it and open it. And I think is downloaded here. Because the very first thing we have to do is obviously, how do I exit out of full screen from the PowerPoint? Ah, sweet. Sweet. And then activity. That's not what it was supposed to be. Oh my gosh. I won't upload it because it's supposed to be, but it's not a big deal. So if you open up that data sheet and if you look at it, you can see there's a bunch of averages with a bunch of behaviors listed on top. And so this study was looking at or measuring the giraffe behavior, and it's looking to see if there's a difference between new and old giraffes. And so if you look at the Excel sheet, you probably see that it's a bunch of averages of datas. And we want to see, well, what is the best, I don't know, what's the best variable to represent being social? Is it when the giraffes sniff each other's butts? Is it when the giraffes lick each other? What about when the giraffes do the little neck thing and they smack each other a bunch of times? Is that a giraffe being social? And so that's what we're going to use a factor analysis to try and reduce all of these data points in that GF activity file and try and come up with a latent variable that best describes social, instead of us just trying to assume giraffes bumping their necks into each other is a loving act. And so if you've downloaded the activity, if you downloaded that one, let's see if I can. Where's R on this? Oh God, that's not the one I want. Where's our Oh, okay. Well, then maybe I won't. You save it for next on the actual analysis. But this is awful. Where's it? You have to launch that? That's okay. We only have a couple minutes anyway, so.
Then you have to click it and then we're sitting.
That's ridiculous, but that's okay. So the test is actually super straightforward. What you're gonna do is load into R what I did, because it makes it easier, at least from my perspective, is I loaded into 2 files that I've gave to you guys. One of them was the activity file that hopefully you looked at and you saw that it's got a bunch of different variables. And then I uploaded this one as well that has the FA, that means the factor analysis. The only difference between these two is that this one is missing that first 2 identifying rows, the age and the names of the drafts. The reason why I didn't want you guys to do the select minus thing where you just take those out is because you're going to actually use this in R to add something on top of it and then export it out. And I just found that easier to have them both loaded up than just trying to, you won't use this for anything. We'll use that. And then we're just going to do something of this and then add it back to that. And then you export it. It was just a lot easier than having to do the minus select thing and different stuff like that. And so in our studio, if you could try to open up the data GF activity. Oh, cool. Oh my gosh. Let's see if my, I didn't even mention a very important thing is that you have to actually add one thing to your Pac-Man. And I should have said this in the beginning, but I must have just missed it. You have to add psych to your Pac-Man right here. So you have to load that in. You need that package to run these tests. So you have to add that to your Pac-Man little thing to get that loaded up. And that's probably going to take the whole time, but I put it right in the homework, sorry, the class data sets. Should be a zipped PCA data, I think it's called. You found it? Yeah. And that's just got all of our data files. So you can just pretty much just copy that, put it right into your project's data folder. That's what I just did with my project that I have up here. And so we're like literally going to run out of time in like a minute. So I guess I'll touch more about this in Thursday, but I also put this PowerPoint up there. And so you could run the code more if you want to and see what it looks like, but it is not that exciting. It's very much like, I'll show you what I mean. It's just like a lot of numbers. You have to run the fit thing that's right here. This is the actual factor analysis. We're just calling it fit. You can call it whatever you want, but it's the one I use. FA is a factor analysis. Don't do the WDF. That's not what that's supposed to be. This is supposed to be, in this case, GF or whatever file you name it as. I put GF because we're working on this data sheet right there. N is number of factors. We'll do 4, but we're going to change that multiple times. And then rotation, varmax, and missing F. When you run that, it's just going to give you a bunch of these little warning messages, which I take as it saying that it worked. And then you're going to then just do the print step that's right after it, the print, and then fit, which is your factor analysis, digits, which will be 2. That's just saying how many like digits we want to see. You can change that to whatever you want. 2 is a lot easier to look at than more than 2. Cutoff 0, sort by true. If you run those, if you're following along, hopefully, and you print the factor analysis, you get a bunch of numbers. None of those are p-values. None of those are, we're not doing any kind of like significant testing with anything. We're just trying to do what I said before. We're trying to take all the correlation between all the variables and load them onto a latent variable that better describes the variation than the actual variables themselves. If you look at this SS, cool. Oh yeah, it is. Okay.
Variables themselves. If you look at
Oh. Yep. Alexa's freaking out.
No software, no profit, sorry.
I don't know. That's why I put GF. Yes, I can. I also uploaded this PowerPoint on Canvas as well. You should be able to find this PowerPoint, so. I'll double check tonight too, to make sure that I did.
Maybe you could call this.
I think so, yeah. I'll double check for sure. Oh, I want to eject, but I can't access this because of this silly little menu.
I would restart with all that stuff.
Yeah, I will tomorrow for the.
Just slow down. Yeah, give this 20 minutes. Get to this point.
Definitely, yeah.
All right.
I knew we were running out of time, so I was trying to get to some point. I didn't know what endpoint I wanted to get to, but
Sure. Gil, you got a question?
Yeah, so we're supposed to, in the plotting theme, we're supposed to change the size to blend with, right? That's
Give me 1 second. Let me get this. Why is it not? Where's the eject?
sometimes, okay, there you go.
Right there. Okay, you're good.
in the plotting theme, we're supposed to change the last size. Yeah, but when I do that, it just doesn't run.
That's because you haven't updated already.
Oh, yeah.
That's
right.
nothing more than that. There's something that happened very recently. I did update, so I'm getting it out.
Yeah, it was bugging me like a while back. but
Yeah.
Updating me, and I just go by the new one. So,
That's not a
yeah,
way to it.
Yeah, I mean, I'll update.
Both are-
All
All right.
Oh,
Yeah. So you have a good day.
All right. This graduate students honors. Connor, you're still here, right?
Yep, I'm still here.
All right. Manuel, you honors? Nope. Yeah, looks like all of our honor students said, yeah, no thanks. Just- which is fine. All right, so how do you guys want to do this final project? Oh, get off it. Give me a break. First thing, you want to do it. Second thing, you need to do it. Third thing is just figuring out time frame, timing, and how you want to go about it. So the basic idea, just please turn off. The basic idea is you're going to analyze data, your data set, the data set I give you. You're going to essentially develop a results section. It should address an overall point. In the class, we keep things very simple, intentionally. This is when you sort of flesh it out. You're telling a story. It's not about the interpretation, it's not about the discussion, it's not about the introduction. It's literally about taking data, telling a story with that data. Okay? Now, there are a few pragmatic ways in which we can do this. One, I start with the data. Mentioned it before, but I haven't really brought it up too often. How many of the data sets that you want to explore? Maybe it's something associated with work you've already been doing. Maybe it's something associated with a bridge off the project that needs to get published, but someone hasn't jumped on it yet, so it's a good time to do it. Maybe it's just something that you like. Next, I see your arm. Did you raise your hand to say you had data you want? Yeah, Joe, Nick, what do you got? Sean. Go ahead, one more time. Oh, how, okay, okay. Okay, Julie, what do you got? Perry Cordace data. Okay, thanks. Okay. Great, great. So if you do not have your own data, I'd be happy to supply you with any variety of data. We'll get together for 10, 15 minutes, and we'll just talk through some options you can play with. With the data, you decide what to do. There are multiple different correct approaches. There are also incorrect approaches. This is not a graded effort. I'm in a pass-fail effort. It is a do it until it's right effort. So you do it. It's cool. You're done. If it's not, you say, nope. Or if you tell me what you're doing with it, it doesn't make sense for what you actually did, nope. Or if you do something that's not the right approach for it, nope. And then you can redo it until it's yup. This is not to be long-winded. It's not to be extra laborious. It's really for two purposes. One, to let you play for real and let you play really, where life is not about a grade. Life is very simple. You succeed or you fail. There's only two endpoints in life. And when you fail, what do? You do it again. And when you fail a second time, what do? You do it again. And how many times could you actually go through something until it gets right? Many times as it takes. Just no big deal. No big deal. So this is what I'm going to propose. But you can make a choice in this. I'm going to give you two options. This came up a little bit from a great question earlier today. As far as I'm concerned, everyone's on good footing. You know, what do you need for a graduate class to pass? A B. It's weird. Doesn't make any sense to me in a million years. It's stupid. Passing grade strikes me as a D and above, but we have these arbitrary rules of B and above for graduate students, C and above for undergrads. Someone please explain to me the logic someday and I'll be very happy. And a D and above, you've got some basic knowledge with a D. You do. You may not want that, but it's not about what you want or don't want, it's about sort of overall development, no big deal. So we got two choices. If you want to finish the project within a time frame, I don't think any of you should be concerned about this, about still making an offer. And you can do that. And if it is a pass, because again, this project is pass or fail, no matter what the final grade in this class is, it's a B. Because you've basically done the core of the class. And now you're able to work with data, tell a story with it. But that has to be done in very short order. I don't think you have the time. So I'm going to give you the realistic option. The realistic option is I'll give you a grade for this class. No big deal. And I'm happy with what everyone's doing. I think it's been a good class. I've never told you guys to do this before. Can someone please remind me on Thursday to remind you all to actually do the class evaluation? You know how many people have done it? Oh, that's new. You've done it? So now one, because there wasn't one a few days ago. It was still zero. Yeah, I want your evaluation. Thank you. It was zero the other day. So maybe you did it, and that's great. Don't do it now. Yes, boy. Good. So one person has. Thank you, Julie. And it's anonymous. So I won't know who did it at all. One person did it. But the other option is, guess who you get next semester? Me. So give me the grade now, and then this project is held over to the next semester. And that one becomes an incomplete if it's not done. Does that make sense? I think it's easier. And that gives you more time to do something. If you find a data set that you really want to work with it. Some of the data that I have that's immediately available, which is kind of cool, is sea turtle nesting behavior in Collier County for about the past, what is that, past 30 years, 40 years, somewhere in that ballpark. And it's just comprehensive. It's all the citizen science data that's gone onto it. And we're not allowed to publish it because Collier County's gone all wiggy, but doesn't mean we can't play. And then data set about endocrine disruptors on female fish development throughout the county. Yeah, the gamboos, yeah. Yep. And there's a few others that would be fun to play with. But those are sort of two medium ones I'm trying to combine. Nah. Any questions? So what it sounds like is we'll take option B, do the project. It needs to be done by spring. You can get started with it now. You can wait. Do not feel rushed. Treat it as like science, as we do things when we become available. No big deal. Lucy first, and then yeah, for a narrative, a section of the results. Section of the results with all the corresponding and appropriate figures. Nope, it's all about biostats. You don't even have to interpret it. There's no thinking involved in that regard. You're doing the results section. And you're doing sort of a section of results. I don't even need you to do an entire results story. You know, when you look at results that tend to be 4 or 5 parts that sort of make up an overall result, I need a piece of it. I need you to sort of tell me a novel story with it. Not the full thing. If you want to go for the full thing, that is absolutely available to you. Happy to do it. But what I want you to do is work with something that's novel, work with something where we don't have a definitive answer, look at the data, figure out a question, figure out the type of things you need to evaluate to get an answer to that question. Evaluate that question. Do the stats which are appropriate for that question. Create the figures as they should be for that question. Make sense? Gabrielle? Yep. Yeah, you're done. You'll get it right in this class. Yep. I have you in research mentorship. You don't give it to me by the spring, you got an incomplete research mentorship. Nothing. I haven't talked to Dr. Rhodes to see if she agrees. She'll love it. Oh, Connor's in my ear right here. Yeah. Connor, do you have any questions with that?
Yeah, so from my understanding, we are taking option B and we will be submitting this by the spring semester. And if we do not submit it by then, we get an incomplete in research mentorship, but we still get a fulfilled grade requirement in this class. So we still can get a finalized grade in this class.
Just confirming, Connor says we get a finalized grade in this class, correct? Yep. And that you'll be able to continue the project into the spring. Yep. And that because you're in research mentorship, I'm allowed to hound you on a weekly basis. Where's my data? Yep. And therefore, if you've seen, what is that? Does anyone remember that 80s movie, ski movie? Better Off Dead with a kid. I want my $2. I want my data. So, yep. And if you are totally negligent, you really should be done by spring break. If you're completely negligent, I am able to continue hounding you. And if you completely say, I don't care, I'm not going to do anything, then we get an eye for that. Yep.
Okay, sounds good. And I guess I can.
15 weeks with 15 tries, assuming that you try once a week and you get 14 not goods, and then finally sure, you're fine, we're done. Connor, go ahead.
I guess this is more personal to you, so I'm wondering,
wait,
I can talk to you later about it. Yeah.
Anything else? Questions with this? actually, no. I know we've been talking about the syllabus, and there'll be 3 things that we're looking at. How to be mentored, how to mentor, and how to instruct. We're going to be combining sort of those 3 pieces within this. You will be heavily responsible for a lot of that course. It'll be a little bit like the way we do advanced biostats, where each one of us is responsible on different weeks, including myself, and these guys for going through different things. We'll be doing that here. How to get mentored, how to mentor, and teaching. We are not going to bring random people into the room and then say, mentor them, and then sort of like allow the person to see their wondering what is going on. No. In fact, some of the, and there'll be a variety of different things that we're still working on, honestly. But one of the things that we talked about today was how you find and how you use research to inform best practices. And one of the things that came up yesterday was a mentoring example for Ella that was based on a paper I read 6 months ago, and I think came out less than a year ago, 9 months ago. And sort of what advice I would have given this one graduate student changed pretty dramatically based on that paper and sort of looking at that and how that can inform. So that was just sort of one example. It'll be a little bit discussion based, so it'll be a little bit project based, so a little bit traditional class based, and it'll be a little bit, what is the right word for it? What do you do play acting when you sort of adopt role playing? Thank you. Role playing base. And you are taking it, right? Or no? Good. Yeah, because you should be. No, you should be taking this one as well. Yeah. All right. You guys are playing. This is not Dungeons and Dragons. You guys are playing Dungeons and Dragons? Good. No, you're not going to abuse someone. No. Diana, did you have a question? It's gonna, yeah. And we're still working out the details, and we very intentionally want you guys to be involved in making those choices. Again, a little bit like what we did with biostat, advanced biostats. I had a basic idea, but then we basically designed the curriculum, right? Yeah. Any other questions? All right, get out of here. Have a great night. Connor, I still got you in my ear if you have any questions.
Yeah, real briefly, I'm excited about the premise of this. So we will have a full, I mean, we're working till spring break, essentially. That's the goal, working with the data set. I was wondering if I can maybe use the data that I'm collecting now, or I also would like to express curiosity for the sea turtle data set. Like, I'm excited for the options for this.
Yeah, I think the data that you have now is a good start. I'm not sure it's comprehensive enough for sort of a narrative at this point. But there may be other data that Dr. Ullman has in terms of the gopher tortoises, which may be very appropriate. And then, of course, the sea turtles also might be of interest.
Okay, cool.
Okay, so I think
that's all I had. All right.
Okay.
Thank you very much.
See you, buddy. Bye.
Bye.
Same answer. 100%.